Welcome to online class again. Myself Tantuboy from Sri Jharkhand Class 2 High School Tara, Jammu. Today we will discuss the next part of the chapter chemical bonding. In the previous class we have discussed the bond-haber energy cycle and also show the energy term involved during this cycle for NaCl. So here notice in the board that the previous work in the board has shown. So during the formation of NaCl from their stable atoms Na and Cl2, the energy terms involved in bond-haber energy cycles are sublimation energy, that is the required energy to change solid NaCl into sodium into a sodium gas. Second one is the ionization energy, which will change Na into a Na plus. Next one, half of dissociation energy. This is the amount of energy. Dissociation energy is the amount of energy required to dissociate a bond for one molecule. Next one is electron affinity. It is the amount of energy released during the acceptance of one electron in the valence shell of a free gaseous gas. तो ये another one is lattice energy. तो ये जो energy terms है, if all the terms except this is to be given, then from this we can calculate lattice energy of NaCl. Today let us take another example for this bond-haber energy cycle and notice how the lattice energy of magnesium oxide can be calculated using this cycle. Let us take the example of magnesium oxide, MgO. MgO solid is formed from their stable atom magnesium solid plus half of oxygen molecule in gas. So this process, the heat released is known as heat of formation delta HA. Next process is the changing of magnesium from solid to magnesium gas, Mg gas, and the energy term involved for this process is loss of sublimation energy. Next one is Mg gas to Mg plus gas. The energy term involved in this process is known as first ionization energy, IE1. Notice here that during the formation of magnesium oxide, Mg acquires 2 units of positive charge and oxygen acquires 2 units of negative charge. So here magnesium plus ion have to release one more electron so that it will change into a di-positive cation. So for this the process, here minus of one electron, another electron, the energy term involved is called ionization energy, Mg plus 2 gas. So this is the successive ionization energy. The energy required to remove one electron, first one electron from the valence shell is I1. Then the energy required to remove second one electron from the unipositive cation is called I2. And always successive IPs are higher, that is I2 is greater than I1. Next, first O2 undergoes dissociation to form O. Yes. And the energy term involved here is dissociation energy by, क्योंकि एक मोल के लिए dissociation energy होता है, या half mole of oxygen is involved, so dissociation energy by. Next, O minus gas. The energy term involved is electron affinity 1. This is negative because when an atom in free gaseous state accepts one electron in the valence shell, then some amount of energy is released, which is known as electron gain enthalpy or electron affinity. Second process is another acceptance of electron to form into a bi-negative anion O2 minus gas. This is EA. But remind here, the first ionization enthalpy is exothermic, that is heat releasing process. But for the second electron gain enthalpy, it will be endothermic, that is energy requiring process. So this will be plus, because after the acceptance of one electron, the atom becomes negatively charged anion, and for such negative charge ion, it is very much difficult to enter another one electron into its valence shell. For this process, some amount of energy is to be required, and this energy is called EA2 or electron affinity 2. So first electron gain enthalpy is negative, and the higher, that is second, third, fourth, and so on, electron gain enthalpies are always positive, that is heat requiring. Next, Mg2 plus gas, electrostatic force of attraction through combined with O2 minus gas to form MgO solid. And this process Mg2 plus gas plus of O2 minus gas to form MgO solid. In this process, the heat release, the heat energy release or the energy released is known as lattice energy minus OK. Now let us see how many energy terms are involved in the steps. So here, according to the Hess law, we know that if a process occurs in one step, then the heat change will always be equal to the sum of the heat change associated in the multiple steps. So we can write delta HA equal to sublimation energy plus of I1 plus I2 plus dissociation energy by 2 minus EA1 plus EA2 minus E, lattice energy. So these are the energy terms involved when MgO, magnesium oxide, is formed from their constituent stable and pure element. So by knowing all the terms like sublimation energy, total ionization energy, dissociation energy, electron affinity 1 to heat of formation, we can calculate the lattice energy. Clear? तो ये हो गया Born-Haber energy cycle from which we can calculate the lattice energy of a ionic compound. Next, we will discuss the factor affecting the lattice energy. आप देखते हैं कौन कौन सी फैक्टर है जिसके ऊपर लैटिस एनर्जी डिपेंडेंट है. Let us take the factor affecting the lattice energy of a molecule. Factors affecting the lattice energy of a molecule. To understand this कि कौन कौन सी फैक्टर लैटिस एनर्जी से डिपेंडेंट है, we can write a equation known as Born-Lande equation. Born-Lande equation. So according to Born-Lande equation, lattice energy is equal to minus Na into m j plus j minus square by r into 1 minus 1 by m. This is the equation of lattice energy from which we can correlate the factors that which lattice energy depend. So let us know the terms involved in this equation. So U is lattice energy, Ma Avogadro's number, M equal to Magellan constant, N is the Magellan constant, J plus charge of cation, J minus charge of anion, E equal to unit charge, that is equal to 4.8 into 10 to the power minus 10 ESU or 1.6 into 10 to the power minus 9 coulomb, and N equal to Born exponent. So these are the identity of the terms involved in Born-Lande equation, where U is the lattice energy, Na is Avogadro number, that is equal to 6.023 into 10 power 23. So that is equal to 6.023 into 10 power 23. N is a Magellan constant. Z plus is the charge of cation. Z minus is the charge of anion. E is the unit charge, and that is equal to 1.6 into 10 to the power minus 19 coulomb. And N is called the bond exponent. Clear? So from this equation we can see that lattice energy is directly proportional to the charge of cation and anion, and inversely proportional to the interatomic distance r. So from this equation we can say that U is proportional to charge, that is charge of cation and anion, and U is proportional to 1 by R, distance, internuclear distance. So with the increase of charge both for cation and anion, lattice energy increases, and with the increase of distance, which distance? Interatomic distance, that is also related to size, lattice energy decreases. So U increases with charge increasing, चार्ज इंक्रीज होने के साथ साथ लैटिस एनर्जी इंक्रीज होती है. अनदर वन, U increases with डिस्टेंस डिक्रीज होने के साथ साथ, इंटरन्यूक्लियर डिस्टेंस डिक्रीज होने के साथ साथ लैटिस एनर्जी इंक्रीज होती है. एक के साथ डायरेक्टली प्रोपोर्शनल, एक के साथ इनवर्सली प्रोपोर्शनल. तो अब देखते हैं how the lattice energy affect in the stability of a ionic compound. So पहले जो डिस्टेंस और R इक्वल टू इंटर एटॉमिक डिस्टेंस, R is interatomic distance that is proportional to size of atom. For example, let us take these are two atoms. For example, we take two atoms like X, X. This is the interatomic distance. This is equal to R. With the increase in size of atom, interatomic distance also increases. Now let us take another atom with larger size Y. This is also Y. In that case, this is the interatomic distance R. So from this diagram or from this picture, it is clear that smaller atoms have small internuclear distance, small interatomic distance, and larger atoms have larger interatomic distance. अब लैटिस एनर्जी के साथ आयनिक कंपाउंड की स्टेबिलिटी की क्या रिलेशन है? तो lattice energy U is directly proportional to stability of an ionic compound. That means lattice energy increase होने के साथ साथ किसी भी ionic compound की stability increase होती है. Why? Because we defined previously कि lattice energy is the amount of released energy. So greater the release of energy during the formation of the ionic compound, lower will be the potential energy of the system and hence greater will be the stability. So कोई भी आयोनिक कंपाउंड की लैटिस एनर्जी ज़्यादा होने के साथ साथ दिस आयोनिक कंपाउंड विल ऑल्सो बी गेट हायर स्टेबिलिटी. अच्छा, तो ये हो गया, दिस इज द रिलेशन बिटवीन लैटिस एनर्जी एंड स्टेबिलिटी. लेट अस एंड ऑल्सो ionic compound percentage of ionic character, that is also be proportional. Lattice energy U is proportional to ionic character. I discussed previously that कोई भी bond 100% ionic या 100% covalent नहीं होता. So in a ionic compound there must be some percentage of covalent character, but the percentage of ionic character in a ionic compound will increase with the increase of lattice energy. Let us take few examples how this varies ionic characters. Let us take NaCl, NaF, NaCl, NaBr, NaI. So in these four compounds, both have same cation with same size and same positive charge, that is Na plus, with one unit positive charge, but the anions are different here. It is in sodium chloride it is F minus, in sodium chloride it is Cl minus, in sodium bromide it is Br minus, and in sodium iodide it is I minus. All the anions F minus, Cl minus, Br minus and I minus have one unit negative charge, but down the group size increases. As a result, internuclear distance R decreases. So the lattice energy decreases. As a result, ionic character so most ionic, तो क्या होगा, from top to bottom size increases. साइज increase होने के साथ साथ distance जो R distance increases. With the increasing distance lattice energy decreases, since R and U inversely related. As the lattice energy decreases, ionic character of the compound will also decreases. Let us take another example. Let us take another example. NaCl and MgCl2. Which one is more ionic? Question is, which one is more ionic? So in NaCl, cation is Na plus and anion is Cl minus. In MgCl2, cation is Mg plus 2 and anion is Cl minus. So in both sodium chloride and magnesium chloride, anions are same with one unit negative charge, but in NaCl, cation has one unit positive charge, and in MgCl2, cation is 2 unit positive charge. So according to the charge factor, lattice energy of MgCl2 is more than NaCl. So according to, so only if we consider the charge factor, then lattice energy of MgCl2 will be higher than the NaCl, because in MgCl2 the cation Mg2 plus has 2 unit positive charge, rather in NaCl Na plus has 1 unit positive charge. But when we consider size, size of Na plus is larger than Mg plus 2. But if we consider the size factor, then being the size of Mg2 plus is less than Na plus, the lattice energy of Mg2 plus will also be high. Being the size of Mg2 plus is less, MgCl2 में Mg2 plus का lattice energy, so lattice energy will be MgCl2 larger than NaCl2, small size of magnesium chloride. But one important fact, note that if charge and size factor contradict with each other, that means when charge factor indicates that lattice energy of one compound is higher, but size factor indicates that lattice energy of that compound is lower. That means when charge factor and the size factor contradict with each other, then you always give the priority to charge. इस स्थिति में क्या होगा, जब चार्ज फैक्टर और साइज फैक्टर एक दूसरे के कॉन्ट्रडिक्शन में होते हैं, तब हमेशा चार्ज फैक्टर को प्रायोरिटी दिया जाएगा. दैट मीन्स दैट कंपाउंड will possess higher lattice energy which has higher charge density or higher positive or negative charge. तो ये है आयनिक कंपाउंड की लैटिस एनर्जी की वेरिएशन. तो लैटिस एनर्जी बेसिकली इन दोनों चीजों पे डिपेंडेंट होता है. अच्छा, नेक्स्ट we will discuss hydration energy. Now, this was the lattice energy. This is also a relation. Now we will discuss hydration energy of ionic compounds. Now we will discuss the hydration energy of ionic compounds. तो क्या हाइड्रेशन या सॉल्वेशन, this is the process. The process is known as hydration या solvation, and the energy associated with this process is known as hydration energy or solvation energy. So let us take an ionic compound MX solid. When it will give into a water which is solvent here, then the water molecule try to decrease the electrostatic force operating between this ionic compound. As a result, this cation and anion becomes free. That is M plus aqueous plus of X minus aqueous plus of NH, and this energy is called hydration energy. तो हाइड्रोजन एनर्जी क्या है? जब कोई भी आयनिक कंपाउंड is to be taken in water, then there occurs the hydration of the ionic compound, which is such as this is positively charged cation will be surrounded by water molecule like this. This is the molecule of water. So this process is called solvation, and this is simply written as A plus aqueous. That means जो cation था that will surrounded by the water molecules. As a result, the force between M is decreases. The force between electrostatic force between M and S decreases because water molecule makes a barrier, makes a wall between M and X by this one. This process is called solvation, and in this process the amount of energy released is called solvation energy. Similarly, the anion will also be surrounded by the water molecule like that way. H, OH, H, OH, H, OH, H, OH. That will equal to X minus. Now, this process is called solvation, or being water is here solvent, so this process is called hydration. तो हाइड्रेशन के बाद जो कैटायन और एनायन स्ट्रॉन्ग इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन से एक दोनों के पास थे वो एक दूसरे से अलग हो जाते हैं. As a result, they are formed hydrated cation and hydrated anion. Now, the factor that depends on extent of hydration. That means the factor affecting the process of solvation. So, which are the important factors that will affect the process of hydration? The first one, the process is only one process, that is charge density. Phi equal to Q by R. That is ionic potential, which is called also be called ionic potential. Greater the value of ionic potential, greater will be the extent of solvation. That means phi is directly proportional. That means if phi is directly proportional to extent of solvation. अब phi जो है ionic potential जो है that is depends on charge and r, radius, distance. So phi equal to charge and r equal to r, that is size, charge that is q. तो क्या होता है? What happens if the charge of an ionic compound increases, then the extent of solvation increases. For example, Na plus, Mg2 plus, Al3 plus. Between among these three cations, charge is that being Al possesses 3 units of positive charge, so the extent of solvation will be maximum for aluminium and minimum for sodium, because it has only one unit positive charge. So with the increase of charge, extent of solvation increases. So we can say extent of solvation proportional to charge. Another one, phi is inversely proportional to psi. Let us take another example: lithium, sodium, potassium, rubidium, cesium, Li plus, Na plus, K plus. These are the group 1 alkali metal ions. For the alkali metal ions, all have unipositive cation, positive charge. For group 1 alkali metal ions, lithium plus, Na plus, K plus, Rb plus, Cs plus, all have one unit of positive charge. But down the group, size increases. As size increases, ionic potential decreases. During the decrease of ionic potential, extent of solvation also be decreases. So the extent of solvation is maximum for Li plus and minimum for Cs plus. So क्या हो गया? तो यहाँ सॉल्वेशन सबसे ज़्यादा, तो एक्सटेंट ऑफ सॉल्वेशन for alkali metal cation is that Na plus greater than K plus greater than Li plus greater than Rb plus greater than Cs. So top to bottom size increases, as a result height decreases, extent of solvation decreases. क्योंकि extent of solvation decreases, क्योंकि साइज के साथ सॉल्वेशन इन्वर्सली रिलेटेड है, एक्सटेंट ऑफ सॉल्वेशन इन्वर्सली रिलेटेड। अब क्या होता है? शो हाइड्रेटेड radii being lithium plus ion gets more sorbated or more hydrated or more surrounded by the water molecule. The hydrated radii, that means the radius in aqueous solution of Li plus aqueous is तो हाइड्रेशन, एक्सटेंट ऑफ हाइड्रेशन सबसे ज़्यादा Li प्लस। एक्सटेंट ऑफ सॉल्वेशन साइज इंक्रीज होती है, साइज इंक्रीज होने के साथ साथ फाइव इंक्रीज होती है, फाइव इंक्रीज होने से एक्सटेंट ऑफ सॉल्वेशन तो हाइड्रेटेड रेडियाई लिथियम की सबसे ज़्यादा हो जाती है। हाइड्रेटेड रेडियाई Li प्लस मैक्सिमम, देन Na प्लस aqueous, K प्लस aqueous, Rb plus aqueous, and so on. So we can say that in free state, the radii of Li plus is minimum, but in aqueous solution, that means in hydrated form, the hydrated radii of Li plus is maximum, because the extent of hydration for lithium is very high. As a result, large number of water molecules are surrounded Li plus ion. As a result, hydrated radii of Li plus सबसे ज़्यादा होती है। As a result क्या होता है? The ionic mobility in aqueous solution Li plus की सबसे कम होती है। इनकी साइज ज़्यादा होने से aqueous solution में Li प्लस की जो आयोनिक मोबिलिटी होती है वो सबसे कम होती है। ऐसे रिजल्ट इलेक्ट्रिकल कंडक्टिविटी ऑफ Li प्लस विल आल्सो बी लेस। ऑन द अदर हैंड Na प्लस K प्लस Rb प्लस इंक्रीज होती है। तो ये था solvation and the factor affecting the hydration, process of hydration. Next, we will discuss about covalent bonding. Let us discuss covalent bonding. तो ये एक ठीक, लेट अस स्टार्ट द अनदर बॉन्डिंग। तो ये जो आयोनिक बॉन्डिंग थे, आयोनिक बॉन्डिंग्स क्या है, आयोनिक बॉन्डिंग कैसे फॉर्मेशन होता है, आयोनिक कंपाउंड्स का क्या क्या प्रॉपर्टीज है, लैटिस एनर्जी क्या है, हाउ टू कैलकुलेट लैटिस एनर्जी, और आयोनिक कैरेक्टर्स, लैटिस एनर्जी कौन कौन से फैक्टर के ऊपर डिपेंडेंट है, आयोनिक कैरेक्टर कैसे चेंजेस होते हैं। तो ये सारे डिस्कशन आयोनिक कंपाउंड के रिलेटेड जो भी था हम लोग कर ले। अब we will discuss about covalent bonding and coordinate bonding. So first is covalent bonding, and we will also discuss co-ordinate bonding. कोवैलेंट बॉन्डिंग क्या है और कोऑर्डिनेट बॉन्डिंग भी क्या है, व्हाट इज द बेसिक डिफरेंस बिटवीन कोवैलेंट बॉन्डिंग एंड कोऑर्डिनेट कोवैलेंट बॉन्डिंग, इसके बारे में हम लोग बताएं। तो फर्स्ट जो कोवैलेंट बॉन्डिंग फॉर्मेशन होता है या जो भी एटम कोवैलेंट बॉन्ड फॉर्मेशन करती है वो सारे नॉन मेटल्स होता है, मतलब कोवैलेंट बॉन्ड्स आर फॉर्म्ड बिटवीन नॉन मेटल्स, बोथ आर इलेक्ट्रोनेगेटिव्स इन नेचर। तो कोवैलेंट बॉन्डिंग फॉर्मेशन होता है बिटवीन नॉन मेटल्स के बीच कोवैलेंट बॉन्डिंग होता है एंड बोथ आर इलेक्ट्रोनेगेटिव इन नेचर। जैसे कि आयोनिक कंपाउंड में एक मेटल एक नॉन मेटल होता है, और जो मेटल होते हैं दैट विल ट्रांसफर द इलेक्ट्रॉन पेयर कंप्लीटली टू द नॉन मेटल, बट इन कोवैलेंट बॉन्डिंग बीइंग बोथ एटम्स आर नॉन मेटल there is not complete transfer of electron from one atom to another। तो इसमें क्या होता है, कैसे बॉन्डिंग होता है, या नॉन मेटल्स कैसे ऑक्टेट फिलअप होता है नॉन मेटल्स में। तो इन दैट केस क्या होता है, इलेक्ट्रॉन पेयर का शेयरिंग होता है, क्या शेयरिंग ऑफ इलेक्ट्रॉन पेयर, शेयरिंग ऑफ इलेक्ट्रॉन। तो कोवैलेंट बॉन्डिंग में जो इलेक्ट्रॉन पेयर्स का शेयरिंग होता है, और द कोवैलेंट इन कोवैलेंट बॉन्डिंग द बॉन्ड फॉर्मिंग एटम्स गेन ऑक्टेट बाय इक्वल शेयरिंग ऑफ इलेक्ट्रॉन पेयर्स। तो इसमें क्या होता है, इन कोवैलेंट बॉन्डिंग जो इलेक्ट्रॉन पेयर का शेयरिंग है दैट इज इक्वल शेयरिंग होता है, मतलब जितने भी एटम्स बॉन्ड फॉर्मेशन में टेक पार्ट किए हैं सारे एटम का कंट्रीब्यूशन इक्वली होता है। बट रेदर इन कोऑर्डिनेट बॉन्डिंग दिस इज आल्सो बी सेम, मोस्टली सेम विथ कोऑर्डिनेट बॉन्डिंग, या देयर विल आल्सो बी शेयरिंग ऑफ इलेक्ट्रॉन पेयर्स, बट हियर क्या होता है, अनइक्वल शेयरिंग होता है। मतलब कोऑर्डिनेटिंग बॉन्ड फॉर्मेशन के टाइम between two bond forming atom only one atom will donate its bond pair to the another atom। so इसमें इक्वली शेयरिंग होता है, इसमें अनइक्वल शेयरिंग होता है। तो दिस इज द बेसिक डिफरेंस बिटवीन कोवैलेंट बॉन्डिंग एंड कोऑर्डिनेट बॉन्डिंग। बट once the bond is formed the properties and the other factor are almost same for covalent bonding and coordinate bonding, only the difference is mode of formation। in that case equal sharing of electron pairs, and in that case unequal sharing of electron pairs takes place। let us take few examples of formation of covalent bonding। let us take a simple example of Cl2, formation of Cl2. So in Cl2 there is two chlorine atom. This is one Cl and this is another Cl. The valence shell of chlorine has 7 electrons. Similarly, this chlorine will also have 7 electrons in their valence shell. So, how these two chlorine atoms can achieve octet? Let us see. These are the 7 valence electrons of chlorine. Here also these are the 7 valence electrons of chlorine. Now these chlorine share these electrons into this. Similarly, these chlorine atom also share these electrons here. As a result, there occurs a bond pair with Cl and this is the bond pair of electrons. So what happens here? This chlorine donate 1 electron, this chlorine will also donate 1 electron and make a bond pair, and that bond pair is equally used by this chlorine atom and also this chlorine atom to show octet. So in that case, this chlorine has 8 electron, this chlorine will also have 8 electrons. So this is the this is called the Lewis dot structure of chlorine. Next, take another example. Let us see for oxygen. O2. What is the Lewis dot structure of oxygen? So here oxygen. This is also another oxygen. The valence shell of oxygen has 6 electrons. Here the valence shell of oxygen also have 6 electrons. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now 7. Sharing the electron. Now we will try to share the electrons. This chlorine share this electron. So this oxygen share 1 electron, this oxygen will also share 1 electron. Now total number of electrons around this oxygen becomes 1, 2, 3, 4, 5, 6, 7. So need to share 1 more electron, that is this and this. As a result, they are formed this. This will be. Now this oxygen has 8 electrons. This oxygen will also have 8 electrons by the formation of 2 bond pairs. So that will be equivalent to O, double bond O. This is the Lewis dot structure of oxygen. So in that way, this oxygen molecule gain octet. There is a double bond. Remember, one bond contains 2 electrons. Here, these atoms, here these electrons are involved in bond formation. So these are called bond pair. And these electrons remains inert, that is does not take part in bond formation. So these are called lone pair. So bond pair are the such electron pairs which are take part in the bond formation, and lone pairs are the such electron pairs which does not take part in the bond formation. Next, let us see CH4. Next, see the Lewis dot structure of CH4. अच्छा remember one important thing. During the drawing of a Lewis dot structure of a covalent molecule, first you have to consider the central atom. Which one is central atom? Central atom. तो which one is central atom? ये आप लोगों को सिलेक्ट करना। तो इसके लिए बहुत ही सिंपल टेक्निक है कि द सेंट्रल एटम विल ऑलवेज बी लीस्ट इन नंबर और लार्ज इन साइज होगा। मतलब if a covalent molecule contains more than one atoms, then the atom with least number is the central atom, or if there is more atoms with least number, then the atom with larger size will be the central atom. So here in CH4, central atom equal to carbon, valence electron equal to 4. So the carbon 2. So this is the valence cell and number of electrons in valence cell is 4. So carbon has 4 valence electrons. Now 1, 2, 3, 4. Carbon has 4 valence electrons. Now look at hydrogen. There is 4 hydrogen atoms, and hydrogen atoms की electronic configuration है 1s1. That is, there is only one electron in hydrogen atom, and for the stable configuration, other than hydrogen, all other elements gain octet, that is 8 electron in their valence shell, but for hydrogen it will achieve duplet, मतलब stable helium configuration. तो हाइड्रोजन की जो 4 इलेक्ट्रॉन है that will be like H. अब क्या हुआ? There occurs a bond. This is 1, 2, 3 and 4. So there will be total 4 carbon hydrogen single bond. In CH4 there is total 4 carbon hydrogen single bond. So this is the Lewis dot structure of methane. Let us take one more example. There is more, यहाँ बहुत सारे कोवैलेंट कंपाउंड्स है जिसके लुईस डॉट स्ट्रक्चर बनाया जा सकता है। तो आज हम लोग और एक एग्जांपल ले लेते हैं CO2 की। तो CO2 की लुईस डॉट स्ट्रक्चर ऐसा होगा। So now in this central atom is carbon. Number of valence electrons equal to 4. Bonded atom oxygen, bonded atom equal to oxygen. Number of valence electrons equal to 6. अब देखते हैं कि CO2 की लुईस डॉट स्ट्रक्चर क्या है। तो इन CO2 carbon is central atom. Let us first form one CO bond here, another CO bond here. अब कार्बन 1 और इलेक्ट्रॉन्स है, ऑक्सीजन में 1 2 3 5 1 2 3 4 5 6 एक bond formation. One electron is take part in the bond, and next to gain octet there will be another one bond. There will also be another one bond. So this is the Lewis dot structure of CO2, in which carbon has 2 double bond, that is 1 2 3 4, total 4 bond pair, no lone pair. in oxygen there is 2 bond pair and 2 lone pair. Similarly, for this oxygen also have 2 bond pairs and 2 lone pairs. Now, this is the Lewis dot structure. Now, अब आप लोगों को कुछ होमवर्क्स दे. You will try the Lewis dot structures of NH3, BCl3, SOCl2, H2SO4, HNO. Let us try to draw the Lewis dot structure of the given compounds yourself. Next, ये है आप लोगों के लिए होमवर्क है कि ये सारे कंपाउंड्स का Lewis dot structure क्या होगा, how to form Lewis dot structure, how to draw Lewis dot structure of these compounds. Try yourself. अच्छा, उसके बाद जो प्रोसेस है, अच्छा, और भी कुछ क्वेश्चंस यहाँ से होता है, जैसे कि लैटिस एनर्जी क्या, ये आप लोग व्हाट इज लैटिस एनर्जी, और भी व्हाट इज द डिफरेंस between covalent bond and co-ordinate bond. So if this, try to find the answers of those questions yourself, and the next part of this chapter we'll discuss in the next video. So thank you for today.